Okay, welcome to Planet Geography. Today we are dealing with the greenhouse effect. Check out my video on the enhanced greenhouse effect if you want to see what climate change is and how climate change is affecting this process. This is a completely natural process and it is responsible for life on Earth. So, it helps to regulate Earth's temperature on average at 10 degrees. That combined with water is what scientists believe to be the key conditions that you need for life on Earth. So the fact you're watching this video, the fact that you exist as a human being, or any species does, is because of this process. So you should really be thanking this process for your existence. I'm sure you are. And if you don't believe me, let's go look at the moon. So the moon does not have an atmosphere. This means that its temperature in the daytime gets to over 100 degrees centigrade. And at night time, its temperature drops to, should be a minus 1000 degrees centigrade. That's a 200-degree range in one day. That is unhospitable, okay? Life can't exist in those conditions, okay? So, the fact that Earth has an atmosphere and a greenhouse effect is why we have life on Earth, okay? I'm not exaggerating there. So, let's delve down into what actually is taking place. So, the sun, I'm going to say a key word here, emits. Emits means to give out, okay? The sun emits shortwave radiation. I always get a bit confused by that because, again, it's going on the longer journey, okay, but we call it shortwave, okay? So shortwave radiation is emitted by the sun and it passes through our atmosphere. Because it's shortwave radiation, it can pass through our greenhouse gases, which I'll add in a second. And it is absorbed by Earth, okay? Heats up our land. We should kind of understand this from kind of atmospheric cells and so on. Heats up our oceans. You should know that from work on cyclones. And then it re-radiates it, and that's another key word there, re-radiates. But when it re-radiates, it changes from shortwave radiation to long-wave radiation. Now that's significant because now our greenhouse gases are going to come into play here, okay? So completely naturally, greenhouse gases have existed in our atmosphere for billions of years, okay? Now, the big four are carbon dioxide, makes up about over 89% of human emissions, carbon dioxide, CO2, nitrous oxide, which comes from planes, CH4, methane, which comes from cows, and then water vapor, which kind of occurs naturally and links to our water cycle. So, what's going to happen is these greenhouse gases in our atmosphere are actually going to absorb some of that long wave radiation, okay? Don't really need to know that, because what you really need to know is that those greenhouse gases, through absorbing the energy, will allow one of two things to happen. They will allow some, but not all, to escape into space, and they will allow some to remain trapped on Earth, okay? And so that stops, it regulates, if you want to use a kind of a tier 2 academic word, it regulates our temperature and keeps it in a hospitable range of 10 degrees, okay? It stops us overheating and stops us getting too cold. Again, just reference the moon. And that is the natural greenhouse effect. So the words you need are shortwave radiation, emits, absorbs, re-radiates, long wave radiation, some escapes into space and some is trapped on Earth, okay? So it's actually quite a nice process. It's not too complicated. So I hope you found that useful. Again, if you want the enhanced greenhouse effect, please check out my other video on that, okay?